Last episode, you logged every run, params, metrics, the model artifact into MLflow tracking, so nothing got lost. But a wall of 40 runs, all scoring 0.9, something doesn't tell you which one is live. This episode answers the next question every team hits. How do you point at one model and say that one? That's the one in production. And prove where it came from. A registry is just a named drawer for one model that fills up with versions over time. You stop thinking run 7f3a's artifact and start thinking fraud classifier version 3. Same model, but now it has an identity that outlives the run that produced it. Versions are cheap and automatic. Every time you register, you get the next integer, version 1, version 2, version 3, forever. What's expensive is knowing which one to trust. So the registry lets you tag a version with a moving label. This one is staging, this one is production. The label moves, the versions don't. Modern MLflow calls those moving labels aliases, and they replace the old fixed stages because a freeform alias is more honest. You can have at champion, at shadow, at canary, not just 3 hard-coded buckets. An alias is a sticky note. You peel off version 2 and slap onto version 3 the moment v3 is ready. And the payoff is one line of loading code that never changes. Your serving app asks for models, fraud classifier at production, and gets whatever version currently wears that sticky note. You promote a new version, the app picks it up, no redeploy, no new path, no edit to the serving code. That indirection is the whole point. Here's a self-contained program that does the full life cycle against a local file-based MLflow. No server needed. We train 2 tiny models, register both under one name, promote the better one to production by alias, then load it back by alias and confirm it's the version we expect. First, we point MLflow at a local directory with set tracking URI. Then we train 2 logistic regression models on the same seeded blob of data, one weak, one strong. So the version numbers and accuracies are deterministic. Each MLflow sclern.log model call passes registered model name but show fraud classifier. And that keyword is what creates version 1 and version 2 automatically. Now we open an MLflow client, the registry's control panel. We read back both versions, compare the accuracy we tagged on each, and pick the winner. This is provenance in action. Every version still carries the run ID that produced it. So which run made production is always answerable. The promotion is one call, client.setRegistered model alias, fraud classifier production, winner version. We also park the other one at staging. No files moved, no copies made. We just pointed 2 sticky notes at 2 version numbers. Run it. Version 1 logs at accuracy 0.79. Version 2 at 0.83. The client confirms 2 registered versions, and the alias production resolves to version 2. The final load, MLflow does sclern.load model. Models at fraud classifier at production, pulls back v2 and rescores it to the same 0.83, proving we loaded exactly the model we promoted. The number on the figure is the number in the terminal. The bar the arrow points to, version 2 at 0.92, is the one the at production load rescored to 0.92. Same value, 2 places, no fudge. A registry is how a model stops being a file and becomes a promise you can point at by name. Next episode, we cache that promise in SH5 FastAPI. We wrap models, fraud classifier at production in an HTTP endpoint and serve a real prediction over the wire.